All right, welcome back. This is Unit 1.2, Polynomial Operations. All right, so last in Unit 1.1, we covered polynomials and how to classify them. All right, now we're going to add, subtract, and multiply polynomials. All right, so for adding and subtracting polynomials, first thing, look at the operation between the polynomials. They'll always either be positive or adding or subtracting, okay? If you're subtracting, you need to make sure you distribute that negative, okay? So if you're adding, you don't have to worry because if you distribute a positive, it doesn't change anything. But when you distribute a negative, it will change your answers inside that parenthesis. So for here, you would still have this 8p squared minus 7p, but then when we distribute that negative to the p, we get a negative p, and usually that wouldn't, most of the time people don't mess up there. It's the second, when we distribute to the second term in that polynomial. So here that would give us a positive, because a negative times a negative gives us a positive p squared. All right, if this makes more sense, you could say this would be a negative 1, and we can distribute that negative 1. It wouldn't change anything, okay? At that point, we would combine like terms. So here is a p squared, and remember, like terms means that they have the same variable and the same exponent. So for example, here we have a p squared and a p squared. So we could add those together and get 9p squared. And then we add the next highest exponent, and that would give us a negative 8p. All right? And the next thing they say here is make sure your solution is in the proper order. Largest exponents first and down to the smallest, and that is called standard form. So here we have the highest exponent, the p squared, and then a p, and that's it. Okay, so I would suggest pausing and trying to do as many as you feel that would be enough to help you feel comfortable doing this. All right, I'm going to continue, and if you are good, you can always fast forward and go to the next part. So here we've got another negative. We need to make sure we distribute that. So we have 5 minus 3m squared minus 6 plus 8m squared. And then we're going to find our combined like terms. Highest would be m squared. So we combine those and we'd end up getting 5m squared. And then the next highest exponent would be our constants, gives us a negative 1. Right? Next one, here we're adding, so we don't have to worry about the distributing. So here we could even just drop out these parentheses. We don't need them anymore. The parentheses, really we need those when we are subtracting, because we'll need to distribute. All right, so here we just combine like terms. 2n plus 2n gives us 4n. And then negative 7 plus 3 gives us a negative 4. Okay, D. Again, we look at the number between the polynomials. Here it's a positive, so we don't need to distribute, so we can just combine like terms. So here's a k to the third and a k to the third. Add those together, we get 7k to the third. And then we combine the next highest exponent, which is the constants. Negative 3 plus 5 is 2. Okay. Next, it's also positive, so we wouldn't need to distribute anything, so we could get rid of those parentheses if we wanted to. Now we want to combine like terms, so here's a negative 8x squared and a 7x squared. Combine those together, we get a negative x squared, or sorry, did I say squared? I meant to the fourth. These are to the fourth. Okay. If you have a negative x to the fourth or just negative 1x to the fourth, those are the same. You could get rid of that 1 because 1 times anything is anything that you're multiplying it to. Okay, next highest, we have this negative 3x to the third, and it's by itself. So we got negative 3x to the third. And then finally, we have our constants. 6 plus 5 is 11. All right, last one, we do have a negative. We're subtracting, so we need to distribute. So here we'd have 7p minus 7p to the fourth plus 3p squared minus 6p to the third minus 1. Okay, and again, oftentimes it's that second term that we distribute to the negative that we have mistakes. Okay, combine like terms. So here we've got negative 7p to the fourth by itself. Then we have a negative 6p to the third by itself. And then we have 3p squared by itself. And then positive 7p by itself. And then a negative 1. So here we don't have to combine anything, but we need to have it in standard form. Highest exponents, so the highest was 4, then 3, then 2, then 1, and then the constant. Okay? All right. If you have any questions, let me know. Adding and subtracting functions. Okay, last time we added and subtracted polynomials, but now we're going to do functions. And these are the functions that they give us, f of x, g of x, and h of x. Okay? It says add and subtract is just like you do with polynomials, only the difference is the notation. So for example, we have for a, we have f of x minus g of x. Well, we know what f of x is. F of x is equal to 3x plus 4, so we can substitute that in. 3x plus 4. Okay, and when we plug anything in, it's a good idea to put those in parentheses, especially when you're subtracting. So here we're doing minus g of x. Well, g of x is right here. G of x is equal to 5x minus 1. Okay, so and this is why you need to have parentheses, is because if you need to distribute, you need to make sure you distribute to both terms. If you didn't have a parenthesis there, you may just say, oh, it's negative 5x minus 1. So here we'll get 3x plus 4 minus 5x plus 1. Combine like terms, we'll get our x's. That gives us a negative 2x. And then we combine the constants. That gives us plus 5. Okay, and if I make any mistakes on these, let me know. Sometimes I go kind of quick and everyone makes mistakes. All right, so here we go. Next one. What in the world is that? F plus g of x? Okay, well, if we look over here, whenever you have something like f plus g of x, it's the same thing as writing it down as f of x plus g of x. Okay, so we could write this if we wanted to right here and say f of x plus g of x. You wouldn't need to write that if you just realize that that's the same. So here you can write down f of x is 3x plus 4, and then we're going to add that to g of x, 5x minus 1. Okay? And since we're adding the polynomials, we don't even need to have those parentheses. We can just combine like terms. So here we get 8x, and then combine the constants. That gives us positive 3. Okay? Next, we have 2 times f of x plus g of x. All right? So it's basically the same thing as we did in b, except instead we're multiplying f of x by 2. So 2 times f of x, which is 3x plus 4, and then we're adding that to g of x, which is 5x minus 1. Okay, we distribute. So it gives us 6x plus 8 plus 5x minus 1. Combine like terms. So combine the x values, gives us 11x, and then we'll combine the constants, that gives us 7. All right, and then finally, d, 5 h minus g. So remember this, we can rewrite this the same way as 5h of x minus g of x. All right, so let's do 5 times h of x, which is a negative x. And if you didn't have a parenthesis, then you'd be looking, oh, that's 5 minus x, but that's not correct. It's 5 times negative x minus g of x, which is 5x minus 1. And then since it's negative, we need to make sure we distribute. So here we can distribute that too if you'd like. So negative 5x minus 5x plus 1. And that ends up giving us, so I can't really go any lower than that. So the adding combined like terms, that would give us negative 10x plus 1. Okay? All right, so that's adding and subtracting functions. Now we're going to do multiplication. All right, so we multiply polynomials using the distributive property, but we end up doing it twice. Okay, so last time, if we didn't, like look at A, if we just only had the 6 and did 2x plus 6, okay, we would distribute like that. All right, now since we have two terms in the front, we have basically a polynomial with two terms and a polynomial with two terms, we need to make sure we distribute to both terms inside for each polynomial. So we'll distribute to there, then we'll distribute to here, then we'll distribute 6 to 2x, and then 6 to 6. Okay? And this is called foiling. Okay? Where f is the first, O is outside, I is inside, and L is last. Okay, so let me go over that really quick. So here if we do, hang on, let me just erase that. All right, so first terms, we multiply the first terms for FOIL, F for first. Then we do outside terms. So those two would be the most outside of the polynomials. And that would be outside, and then we do inside, and then we do last. So those will be the last two terms for each polynomial. Okay? So here we'd go over that. We'd do 3x to 2x. We multiply that. That gives us 6x squared. And then we go and multiply the outside terms. 3x times 6 gives us 18x. Inside terms, that gives us 12x. And then outside terms, that gives us a positive 36. And then we would combine like terms. That would end up giving us 6x squared plus 30x plus 36. Okay? Another way, and now some of you have learned this, it depends on what math teacher you had before, is using something called the box method. Okay, so since we have two terms for each polynomial, we're going to make a 2 by 2 box. Okay, and I don't know if that's probably not big enough. Let me make it a little bigger. So a little bigger. Okay, 2 by 2, because we have 2 by 2 for our polynomials. So I'll write those polynomials. We have 3x, and we have plus 6, and then we have a 2x and a positive 6. All you need to do for the box method is to multiply. So 2x times 3x, that gives us 6x squared. 2x times 6, that gives us 12x. Now we have a 2 times a 3x, that gives us 18x. And then a 6 times a 6 gives us 36. And then all you do is add up all the boxes, which would give you the exact same answer. Okay? All right, sometimes that's useful when you end up having like a trinomial times a trinomial. So if you had like x squared plus x plus 1, and then we're multiplying that, or even if you multiply it by a 2 binomial, like a x plus 1, it's kind of nice to be able to just say, okay, I'm going to put these in a 2 by 3 and plug it in something like that. And then all you just multiply everything, combine like terms. So either way is just fine. You'll end up getting the same answer. All right, so next, again, we'll do FOIL. We'll do first time. Our first gives us 6v squared. Outside, that gives us a negative 2v. Inside, a negative 12v. And then last gives us a positive 4. And then we'll combine these like terms. 6v squared minus 14v plus 4. Okay? And all of the other ones are basically the same. So I think, well, I'll just skip those. If you have any questions, let me know. Those are very, very similar. It's just multiplying different numbers. All right? Multiplying functions. Well, guess what? It's exactly the same as you do when you're adding. All you do is you say, well, here's f of x. Let's replace it with negative x minus 2. Okay, so let's do that. Negative, and we're going to make a parenthesis, negative x minus 2, and then we're going to multiply that by g of x, which is 3x plus 4. Okay, and then you're going to FOIL. Now here we kind of have this negative in the front. You can ignore that and put it in the end, or you can distribute that first. Either way, you'll be fine. The thing is if you distribute this negative, you only distribute it to the first polynomial. You don't distribute to both polynomials. Okay, it's kind of like if you had something like 2 times 2 times 2. Okay, you wouldn't distribute that to both because that would give you 4 times 4, which gives you 16. What you'd get is what you would get would be 4 times 2, and then you'd get 8. So if that makes sense, you only distribute it to the polynomial that's closest. Okay, so if we did that, we'd end up getting a positive x and a positive 2 times 3x plus 4. Okay, again, if you wanted to do those first and do the FOIL and then multiply it by a negative, that'd be fine. So here we would distribute. Here's 3x squared. And we do the outside. That gives us positive 4x. Then we get a positive 6x and then a positive 8. Combine like terms, and that would end up giving us 3x squared plus 10x plus 8. Okay? And again, they're in standard form, highest exponents first, down to the constant. All right? Very similar to when we had something like g plus f of x. All we're doing, this is the same thing as g of x times f of x. Okay? We know what f of x is, we know what g of x, so let's just substitute that in. G of x is 3x plus 4, and f of x is a negative x minus 2. And then we would FOIL. So we multiply the inside, that gives us a negative 3x squared. We do the outside for FOIL, that gives us a negative negative 6x. And we do inside, a negative 4x, and then our last is our negative 8. Combine like terms, that gives us a negative 3x squared, minus 10x, minus 8. So it kind of makes sense that it looks almost the same. Okay, the only difference is the sign, because we put this negative in the front. All right, g of x times h of x. So g of x is 3x plus 4. And we're multiplying that by h of x, which is 6x plus 7. Okay, first, 18x squared. Outside, 21x. Inside, 24x. And then 4 times 7 is 28. These are our like terms that we're going to combine. Gives us 18x squared plus 45x plus 28. Okay, fh of x, again that is f of x times h of x, which is the same thing as negative x minus 2 times 6x plus 7. And then here I'm going to do the box method just to mix it up. Okay, here's going to be my box. And here's my negative x and my negative 2 and my 6x and my 7. Okay, I'm just going to multiply our 6x times a negative x gives us a negative 6x squared. And then 6x times a negative 2 gives us a negative 12x. And then 7 times a negative x gives us a negative 7x. And then 7 times a negative 2 gives you negative 14. Okay? And when you set it up like this, and if your polynomials are in standard form, the things that you combine will always be diagonals. So here we have a negative 6x squared, and then we combine the negative 7x and the negative 12x gives us a negative 19x, and then minus 14. Okay? All right, so that is everything we went over, adding, subtracting, and multiplying polynomials.